And good afternoon, welcome back to the chemical equilibrium. Yesterday we have seen the homogeneous reactions and where the um, products and reactions are same and state. Then we have seen the stoichiometric balance equation, how it is delta n is varying and all, what is the relation between Kc and Kp and all. Now today a small problem we'll see, then heterogeneous equilibrium. Now the problem given is the carbon monoxide reacting with the water in equilibrium with the carbon dioxide gas plus hydrogen gas. This is a liquid and carbon monoxide is a gas, and the reaction is at Kc value equal to 4.24 at 800 degree Kelvin. Now equivalent concentrations of the all thing and initial concentration of the CO and H2O is given as 0.1 molar. This is initial 0.1 molar each. This is what is the equivalent concentrations of all the four. This is the initial value, and Kc is given as 4.24 and 800 degrees centigrade Kelvin is this one. Reaction is given like this. So if you say that means initial this much, this is like this. If somebody is asking a plot a curve, then you should keep it 0.1 is the value of the right side of the top. Product is 0, 0 and all. Fine. Now let the equivalent concentration value is x. That means at equilibrium this will be 0.1 minus x at equilibrium. I am talking at equilibrium because I am talking saying this will be the balanced equation already. So this is the x is the concentration of this one, so this is also x. And then this will be the 0.1 minus x, and another one is also 0.1 minus x. Here xx. Okay, molars. Now what is the Kc? Kc equation equal to, we know that CO2 concentration into H2 concentration by CO concentration into H2O concentration. Nothing but what is the value? CO2 and H2 means x square, x into x, directly I am writing x square by this is a 0.1 minus x whole square. Say okay, the Kc value equal to 4.24. That was given at 800 degrees Kelvin. Now if you see 4.24 into 0.1 minus x whole square equal to x square, then 0.1 x square is 4.24 minus x square. So this side if it is going plus minus yes, so 3.24 x square minus 0.848x plus 0.0424 equal to 0. This is this one here a we have to calculate it as roots as a, this is a, this is b, and this is c. Then value x equal to root of minus b, under root minus b under root b square minus 4ac minus p plus or minus, yes, by 2a entire by, if you are substituting you will get a values of the two values. One is higher than the initial value of the 0.1, another is the lower value. Lower value I will take, lower value will be the x equal to 0.067 and 1.94. One is 0.067 is 0.194. 0.194 we cannot take because it is more than the 0.1. So 0.067 is the x value. So finally The equilibrium concentrations are 0.1 minus 0.067. This is the value of CO, and another one is also same, nothing but 0.033. Another is also 0.033, whereas x is equal to 0.067, 0.067. These are the values. Fine. So now heterogeneous equation. Heterogeneous means all the reactants and processes, at least one or two will be in the different state, solid, liquid, gas. Suppose H2O liquid is in equilibrium with the H2O water, means gas, vapor. This is also heterogeneous system. Normally, generally, the most this thing, calcium carbonate on heating gives you the calcium oxide plus CO2. Here calcium carbonate is solid, calcium oxide is solid, carbon dioxide is a gas. This is a well known this thing and all. If you see the Kc equal to CaO and the CO2 by CaCO3, normally we write, but for the in terms of the concentrations, if you are measuring in the Kp and all, one is the gas and gas pressure if you are measuring, normally the solid concentration will be, and H2O at all, if at all any available, that will be taken as a unity. That means these two are taken as a unity, and Kp will be taken as the CO2 gas pressure of CO2 gas. Very clear here what I am telling. Whenever the solids and liquid heterogeneous phase, solids will be taken as unity. That means calcium oxide and calcium carbonate. If at all in the reaction is water is also there, water also will be taken as normally 0, means unity, and Kp will be equal to the partial product of CO2. That is in the heterogeneous system, normally you have to maintain. So all the time. But here remember all the time for the questions and all, this will be only at equilibrium. Holds good at equilibrium. That is at particular temperature. Remember these two. This will be holds good only at equilibrium and holds good at a particular temperature. In case of the CaCO3 this thing and all, that will be at I think 1100 Kelvin. Only this equilibrium will be there, and there CaO and CaCO3 concentrations will be taken as unity. Similarly, for each reaction, there will be a particular temperature. At that particular temperature, it will be in equilibrium. At that equilibrium, if at all any solids or the water available, that will be taken as a 1. So another simple examples we will take. One more example we will take. That is the silver oxide, Ag2O. Ag2O plus nitric acid, HNO3, gives silver nitrate plus water. Water is a liquid, silver nitrate is the aqueous solution, nitric acid is aqueous, 2 nitric acid, silver oxide is solid. If you are writing Kc, what do we have to write? This I am why I have written this equation is, I am supposed to write like this: AgNO3 concentration H2O by Ag2O and HNO3 square. But what I am writing? H2O I am omitting because it is a liquid. Silver oxide I am omitting because it is a solid. Finally, these two fellows are only available. What is there available? Silver nitrate aqueous and HNO3 aqueous square, where it is at equilibrium, where at particular temperature and pressure. Okay. So always remember, this is holds good only at particular equilibrium, and that will be at particular temperature only for each reaction. So then finally, if we conclude the what are we have read for about the equilibrium constant, the equilibrium constant is independent of initial concentrations. Whatever may be the concentration values are taking, that is independent of the Kc. Even if I am taking 0.2, 0.2 or 0.2, 0.3 whatever you want, equilibrium is independent of the concentrations, right? That is the first, everybody should be, and concentrations of the reactants or products also, whatever it is. But what is it? It is dependent. It is depending on temperature. But that will be a particular if it is attaining an equilibrium. Then, equilibrium constant is applicable only when concentration of the reactants and products have attained a constant value of it. So, Kcv should be written only for the equilibrium, not for anything. The equilibrium constant for the reverse reaction is the inverse of the original this thing. So, and delta n should be the reactants. Then, why we should all find out the equilibrium constant values and what is the use? The uses are mainly three: to predict the extent of a reaction on the basis of its magnitude. Second, predict the direction of the reaction, whether it is the forward direction or reverse direction and all. And find out the at equilibrium what are the concentrations. So to know all those things, one should know about the Kc or Kp. Okay, thank you. Tomorrow we will see the how to predict the extent of a reaction or predict the direction of reaction or calculate the equilibrium concentrations, all.